Okay, the next point is when a liquid is cooled in a controlled situation, crystalline solid is formed. Okay, and when a liquid is cooled, suddenly an amorphous solid forms. This is one more point of difference between crystalline and amorphous solids. The next point of difference is, depending on the reaction conditions like temperature, pressure, etc., sometimes a substance shows two or more crystalline structures. These crystalline structures are called as polymorphosed or polymorphosed. Okay. This phenomena is also called as polymorphism. So, did you understand the meaning of this statement? So it means that a same substance, okay, a same substance at different temperatures or various conditions, temperature, pressure, etc. One substance shows two or more crystalline structures. These crystalline structures are called as polymorphs of each other. Okay, so this is all about the differences between the crystalline solids and amorphous solids. Okay, so there are total about 11 points of difference between the two, and from now on in this chapter we will be studying more about crystalline solids than amorphous solids. So next point or the next subtopic of this chapter will be classification of crystalline solids. We will be going through that in a moment. Okay. Yes. Now coming to classification of crystalline solids. Now on what basis is this classification made, or why are they classified into different types? It is because of, or it is based on the nature of the constituent particles and the intermolecular forces operating between them. This word, intermolecular forces, is the keyword. Okay. Crystalline solids are classified based on the intermolecular forces. Which are the intermolecular forces? Van der Waals force of attraction, hydrogen bonding. Okay. Then what else? So you have to go back to your class 11 chemical bonding and go through the different types of intermolecular forces. So there are different types. Dipole-dipole interactions you have studied, Van der Waals forces, London dispersion forces, and your hydrogen bonding, etc. Okay, so based on what type of intermolecular force is existing between them, they are classified into molecular solids, ionic solids, metallic solids, and covalent or network solids, or it is also called as covalent network solids. Okay. So these are the four classes of crystalline solids. Based on the names, you can tell what type of bond exists between them. Molecular solids comprise of molecules. Molecules attached to each other through various types of bonding again. Based on that, you have a sub-classification of molecular solids. So you have under molecular, polar molecular solids, non-polar molecular solids, and hydrogen bonded solids. Okay, polar molecular, what do you understand by the term polar molecular? Polar means who have a dipole-dipole interaction. Polar, we have very frequently discussed the definition of what is a dipole moment in your class 11th. Correct? I hope you remember it. If you don't, please go back and read the definition. Okay, because unless and until you understand the definition of what is polar, when I say what is a dipole moment, you won't understand what I am talking about right now. Okay, so polar means those molecules who are bonded by a dipole-dipole interaction between the two molecules. Okay, second class is non-polar molecular solids. Okay, so non-polar molecular solids, what kind of bond will exist in between them? There will be a weaker force of attraction, which is that it is the Van der Waals force of attraction. Okay, or they can be bonded by non-polar covalent bonds. Okay, we will see that one by one. Okay, and third is hydrogen bonded solids. Of course, what will be the bond in between these molecules? Hydrogen bonds. Okay, what are hydrogen bonds again? Go back to your class 11, read and then understand. Okay, so this is about molecular solids. Next class is ionic solids. Again, what comes from the name? What do you get from the name? Ionic. Ionic means what? Ionic means cations, anions. These terms come to your mind when you hear ionic? Yes. So, in these type of solids, the constituent particles are cations and anions. Their cations are positively charged particles, anions are negatively charged particles. How they are arranged, what type of force exists between them, we will see one by one. This is just a brief introduction I am giving to you. Okay. Then comes metallic solids. Of course, what is the bond between them? Metallic bond. These are metallic solids and covalent or network solids or covalent network solids. These are having a very strong covalent bond between them. Now, 2 points I have written here. You can see here, melting point in under ionic solids, it's high. And under covalent solids, the melting point is very high. Okay. So, this high and very high is in comparison to what? Molecular solids and metallic solids. Okay. It is higher. Ionic solid melting point is higher than molecular solids. But it will be definitely lower than covalent network solids. Okay. So, ionic solid have a very high melting point and covalent or network solids have a very high melting point. Okay, these 2 points are important. Hence, I have mentioned it under the classification itself so that you note it down. Again, I will emphasize, please note down whatever is being told. Okay, so that it's easy for you to revise and you don't have to go back and watch it again and again. Okay, yeah. So we will move on to one by one the definitions of polar molecular solids and so on. Okay, first is under the category of molecular solids, we'll be studying about polar molecular solids. So, as the name suggests, polar means those molecules having polar covalent bonds. What is a covalent bond? A bond which is formed by sharing of electrons. What is a polar covalent bond? Polar covalent bond is the covalent bond which is formed due to the presence of opposite poles. So during formation it is a polar bond. After formation it is a covalent bond. Okay. The interaction between this is dipole-dipole interaction. So if you know the meaning of what is polar, you will easily get what is a dipole-dipole interaction. Okay, just keep in mind, polar molecular solids have polar covalent bonds and polar dipole-dipole interactions. For those who have not understood what are dipole-dipole interaction, what is the meaning of polar, what is the meaning of covalent, please message me on WhatsApp. I will explain it to you. Okay, rest of them I'm assuming that you know the meaning and I'm talking about it. Okay, so if you don't understand, please message me or text me. I can make a separate video on that and send you. Okay, please let me know. Example of polar molecular solids is HCl and sulfur dioxide. Okay, and the properties of polar molecular solids are that they are soft, they are non-conductors of electricity. Again, why are they non-conductors of electricity? Yes, for conduction of electricity, what is required? Free electrons are required, right? So if the solids do not have free electrons, they will not conduct electricity. Why are the electrons not available? Because they are participating in your covalent bond. Okay, there are no free electrons, hence they are non-conductors of electricity. The melting point is higher than the non-polar molecular solids. Okay, these are the properties, this you have to remember. Next, moving on to non-polar molecular solids. Non-polar molecular solids are those which are exactly opposite to polar. They have zero or nil dipole moment. They do not have a dipole moment. Then what kind of force is there between the molecules? It is Van der Waals force of attraction or non-polar covalent bonds. Either a covalent bond or a Van der Waals force of attraction. Again, you have to know what is Van der Waals force of attraction. Please go and read it again. Okay. Examples of non-polar molecular solids are noble gases. Okay. Argon, helium, neon, krypton, all these noble gases, when exist in the solid form, they are non-polar in nature because of their non-polar nature. And also hydrogen, chlorine, iodine. These are examples of your non-polar molecular solids. Next, moving on to hydrogen bonding. Okay, before talking about hydrogen bonded molecular solids, you know what is a hydrogen bond? Can you recollect the definition of what is a hydrogen bond? A hydrogen bond is a bond between hydrogen and an extremely electronegative or highly electronegative atom. Which are the highly electronegative atoms? Fluorine, oxygen, nitrogen, all these are electronegative atoms. So, the polar covalent bonds between hydrogen and highly electronegative atoms like fluorine, oxygen or nitrogen. Okay. So these are the examples of hydrogen bonded. In these molecules, there is strong hydrogen bonding which binds the molecules of such solids. Okay. Now these solids are either volatile liquids or soft solids. So can you imagine water? Yes, water molecules are bonded by what? Hydrogen bonding. You know the structure of water, right? So water is a volatile liquid, correct? So when you heat it, it evaporates. Or soft solids at room temperature. So when I say soft solid and when I'm talking about water in the ice form, okay, whenever water is in the ice form, unless and until it is not completely turned into water, its temperature is still 0 degrees. Even if you bring it at room temperature, until and unless it fully melts, okay, when it is in the solid form, the inner temperature is still 0 degrees, okay. So it is called as a soft solid at room temperature and pressure, okay, and they are non-conductors of electricity. So this information is about your hydrogen bonded molecular solids. So what is a common point between all the forms of molecular solids? The common point is they are non-conductors of electricity. Okay, that is the only common point. Otherwise, on what basis are they differing? They are differing on the basis of their forces of attraction. Okay, the remaining three classes of your crystalline solids, that is ionic, metallic and your covalent or network solids, I will be discussing in the upcoming video. Okay, till then you study this and please answer the questions which I have sent you. Okay, thank you.